Good morning. Now, this is our class 7 on counters and timers. Here, I have presented only the main points. Uh, Most of the microcontroller applications, we all know that they require counting of external events such as the frequency of pulse train, then or the generation of precise internal time delays between computer actions. That is, anyway, most of the controller applications require the need for counting. That is, it may be the counting of external events or it may be the counting of internal events. So when during this computing or counting task, these counting tasks are usually done using softwares or programs, and so these software loops for counting or timing, it actually will keep the processor engaged all the time, so we won't be able to do other task using the same processor because it will be always engaged in counting. So most of the important tasks will not be accomplished in between. So in order to relieve the microprocessor or the microcontroller from this burden, we make use of okay, they are named as T0 and T1, and they are actually general purpose counters. They are mainly used by the programmer. That is, they can be programmed according to your needs. That is, they can be used to count either internal clock pulses or external events. So when it is acting as a timer, it has to be programmed to count external purpose as a timer, or sometimes if you want it as a counter, it can also be programmed as per our wish. If we want it to function as a timer, we can also program it as according to our wish. So they both of them are programmable. That means they are actually of general purpose use. Now counters are actually divided into two 8-bit registers, and they are called timer low TL0 and TL1, and the other one is high, that is TH0 and TH1 bytes. Now all the counter actions is controlled by the state of the bit in the registers named T mode, that is timer mode control register, and the other one is T-con register, that is timer counter control register. So almost all the counter actions of the microcontroller is controlled by the state of bits in the two registers, namely T mode register and T-con register. Now the configuration of these two registers is very important, that we will deal in the coming sessions. Now T mode is dedicated mainly for the two timers, okay, whereas T-con has got control bits and flags. Then they are given here the bit setup. That is, the first one is the timer control register, and the bit arrangement is shown here. Is TF1. Its full form is timer 1 overflow flag. Then what is its function? It is written. So this is important. The configuration, the bit configuration of T-con register. Similarly, the bit configuration of T mode register is also important. See, this is T mode register, because I am not explaining why, because each of the function is written very clearly, so you can just read through. So the bit configuration and the explanations of T-con register and T mode registers are important, that you will have to learn. Next is timer counter interrupts. uh, we know counters are included on the chip just to relieve the processor from the timing and counting action. Okay, that we already said. Now when the program wishes to count a certain number of internal pulses or external events, then a number will be placed in one of the counters. The number actually represents the maximum count less than the desired count plus 1. So the counter increments from the initial number to the maximum, and then it moved to 0 on the final pulse, and finally it set the timer flag. Now the flag condition can be tested by using an instruction, and that will tell the program that the count has been completed or accomplished, or it will also indicate that the flag may be used to interrupt the program. That is how interrupt of timers and counters works. So that paragraph is enough, no need of drawing this circuit diagram. Next is about timing and the various modes of timing. There are timer mode 0, timer mode 1, timer mode. So first of all, let us see what is timing. Now, if a counter is programmed to a timer, we have said that a counter can be programmed to a timer also. So, if the counter is programmed as a timer, then what it does is that it will count the internal clock frequency of the 8051 oscillator divided by 12D. Okay, now the resultant timer clock is gated, that is, it is fed to a gate to the timer by means of a circuit. So, in order for the oscillator clock pulses to reach the timer, the bit C bar T bar, that is a bit in the T mode register, you can see that in the T mode register, you can see C bar T bar, C, the sixth bit. Okay, that bit in T mode register will be set to 0, whereas bit TRX in T-con register will be set to 1. Then these are the configuration setup, that and the gate bit in T mode register will be 0. So in other words, they have written it in a single sentence, that is, the counter, if the counter is configured as a timer, then the timer pulses are gated to the counter by the run bit and the gate bit or external input bit IT interrupt X bar, that is called INTX bar. Okay, so I think you can write the first sentence, this paragraph you can write, then you can skip all this and finally you can write this sentence. That is enough. Okay, so first write this paragraph, then the final happens to the timer pulses, that will be gated to the counter by the run bit and the gate bit or the external input bit INTX bar. That is enough. Now there are various modes of operation for the timer, and they are, the first one is timer mode 0. So that each of that heading you have to specify and write one or two sentences for that and draw the circuit diagram. So first is timer mode 0. What is its specification? That you have to write as such, that is, setting timer X mode bit in the T mode register will result the THS register as an 8-bit counter and TLX register as a 5-bit counter. That is, the pulse input will be divided by 32D in TL, that is in timer low, so that timer high, that is TH, will count the original oscillator frequency reduced by a total of 384D. So that is the configuration or the arrangement of timer mode 0. So that you will have to write as such. Then after writing that paragraph, you have to draw the corresponding diagram for timer mode 0, that is this one. Okay, this is easy to learn. You are giving pulse input, then TLX 5 bits, THX 8 bits and TFX finally the interrupt. So write that single paragraph, draw the diagram. Next is timer mode 1. It is similar to timer mode 0 except TLX is configured as a full 8-bit counter. In the other one there was a split up. Okay, here it is configured fully as an 8-bit counter, and this happens when the mode bits are set to 0 1B in T mode register. That for the configuration regarding timer mode 1, and after writing that paragraph you have to draw the corresponding diagram for timer mode 1, that is this one. Okay, next one timer mode 2. uh, Setting the mode bits to 10B in T mode will configure the timer to use only TLX counter as an 8-bit counter. Now in this case, THX will hold a value located in TLX register every time the TLX overflows. The timer flag is also set when TLX overflows. Okay, so the THX as well as timer flag is set when the TLX register overflows. Now this mode exhibits an auto reload feature, and that is TLX will count up from the number in THS overflow, and then it is initialized again with the contents of THX. That is enough, no need of writing the example. Then after that you have to draw the corresponding diagram for timer mode 2, this one. Then finally timer mode 3. Here timers 0 and 1 may be programmed to be in mode 0, 1 or 2 independently, but this is not possible for timer mode 3. Here the timers do not operate independently if mode 3 is chosen. Why? Because here placing timer 1 in mode 3 will cause it to stop counting. That is, the control bit TR1 and the timer 1 flag, that is TF1, are used by timer 0. So timer is enough for timer mode 3. Up to that you'll have to write, that is from here to this one, that is enough. Then draw the corresponding diagram for timer mode 3, this one. Okay, now finally counting. What does counting means? Now the only difference between counting and timing is the source of clock pulse to the counter. That is, when used as a timer, clock pulses are sourced from oscillator. That is, clock pulses comes from oscillator through the divide by 12D circuit. Now, but when it is used as a counter, the pin T0 actually supply the pulses to counter 0. In the first case, it was the oscillator that was supplying pulses, but in this case, it is the pin T0 that is supplying the pulses, and pin T1 will be supplying the pulses to counter 1. Then the C bar T bar bit in T mode must be set to 1 to enable pulses from TX pin to reach the control unit. So that paragraph is enough for counting. The second paragraph, they are giving an example, that no need. If you want, you can write a few sentences about the machine cycle. That is, a change on the input from high to low between the sample will increment the counter. That is how the incrementation takes place in the counter. Each high and low state of input pulse will be held as a constant at least for one machine cycle. Okay, so as to ensure reliable counting. So in order to make the counting reliable, each high state impulse or each low state input pulse, so that is it. So you can write, I think that also you can include when you write about counter, that is from this one to this one. Okay, so here what is important is, in this session you will have to understand why counting is needed. Then what are the significances of T-con and T-mode registers, then their bit configuration. T-con and T-mode are very important. Then timer counter interrupt, that paragraph is enough, no need of drawing the circuit diagram. Then which are the three modes of timer modes of operation, that you have to write 1 or 2 sentences regarding each mode and draw the corresponding circuit diagram. Then just a definition, what is meant by counting. Okay, that is enough. Thank you.